and looking at the literature, you wouldn't really know that unless you were being really critical of the material that's out there in the first place. So when you read an article, you can't just take it and base it off facts. You have to go to see the statistics and see that it's correct and make sure that everything's lining up, that they've got all the data that's necessary for you to actually make that reasoned judgment in the first place. Because, you know, there's far too many journal articles that are out there that are just complete and utter nonsense. And you look at them and you go, you can't make that judgment call from that whatsoever. That doesn't make any sense. But that is something I would not have been able to do were it not for going through university and critiquing other papers and thinking to myself, why am I doing this? This has been accepted into a scientific journal. Why should I ever critique this in the first place? And then you start to realize, oh, these people are wrong. They're not necessarily right with everything. Actually, the most famous one is the Occludodaventus, the bird head in the amber. Did you see that by any chance?
I did see that, and I really hadn't thought about whether or not that was plausible. And then there was an article that I just saw recently about dinosaurs were likely warm-blooded.
Yes, and they almost definitely were. People have quoted this term mesothermic, which is way in between the two. But that bird head and amber is actually really interesting because a group of Chinese paleontologists looked at it thereafter and concluded that it wasn't a bird, it was a basal reptile instead. And it is a huge judgment call to say something like that, of course, and to denounce someone's work, but then they gave the data and they look at it and they're like, this is not a bird. What we are presented with here is something completely different. And then you see their data, and then you don't quite know who to believe in the entire diatribe. But being able to critique other people's work is by far one of the most important things, and formulate your own hypotheses in all of this.
Had we been able to do that better, we probably wouldn't have this generation growing up questioning science the same way or wondering. People have been presented suddenly with a massive amount of information they have access to, and no skills on how to tell whether or not that information they're looking at is something that they can actually have confidence in. It's something I spend a lot of time in social media. When I comment on things, it's oftentimes saying, hey, did you fact check it? Because if you go and do this, this is what I get, and try to have people understand, be skeptical. Look at something and doubt it until proven otherwise is important. And I would imagine in your field that that's a big deal because, you're identifying animals, whether they match something you already know about or there's something totally different based on little pieces of information that you're linking
tiny
together.
Pieces of information that we can link together. Yeah.
That when you pick up that bone and I think about my field, how much, I tell people, share your photos of humpbacked whales with us. We can do a lot. And people say, oh, well, I didn't get that shot of the animal breaching, jumping out of the water. And I only had my cell phone from far away. And I tell them, oh, I can tell a lot by a terrible photograph.
Yes, it's very much like that, isn't it? It's so frustrating. And you're right, it does put a lot of disdain in science and almost disbelief as well. You can say this much off a single bone. An example I'll use is a lot of scientists throughout the early 19th, when they were naming taxa, they quite often did it just off the basis of one single bone or one single tooth, and that was it. And so there's a group of sperm whales called Scaldacetus, and they have all the nomenclature you could possibly imagine, and all these wonderful Latin names attributed to them, and they're just on the basis of one single tooth. Sperm whales have dentition that looks exactly the same all the way through the jaw. They're very, very difficult to determine absolutely anything. You definitely can't assign a new species to it. And so you have all these old, beautiful Latin names that are attributed to new species, and you're like, no, that's not a species. That's just not anything whatsoever. I think a lot of it also comes down to the individual scientists writing the articles themselves, and I've used the term white ivory tower for a lot of scientists. And for those of you who don't know that are listening to this, white ivory tower refers to scientists that are so absolutely certain with themselves and the decision to call something as it is, that even if they're wrong, they don't come down from it at all. And they kind of partition the resources from this white ivory tower as well. I know a lot of fantastic scientists, and they're not given the opportunity because of other scientists that are on this white ivory tower and are refusing to get down from it and actually talk to the common people, you know. I'd like to think that the vast majority of paleontologists and scientists are doing the right thing. It's the small minority that are bringing everyone down.
What's the one thing you hope to find, discover, answer the question, put together? What's the epitome, if you can accomplish that in your lifetime, what would it be?
There was actually a specimen that we found the other day, and we can't talk about it, unfortunately, because it's kind of embargoed. But I found it, I found it with other citizen scientists that I was out with at the time. And I honestly could not believe my eyes, and I went, I never thought in a million years that this would ever be discovered, ever. It was quite incredible. And that'll come to light at some point. And it gives me a lot of hope that we'll find other things. I think the gold standard, the holy grail for me of cetacean paleobiology is to find a complete skull of Leviathan, that killer sperm whale. To find a super predator like Leviathan and to find its skull would be able to tell us a lot about what this creature was doing. And especially, I mean, when it comes to a lot of paleontologists, when you study whales, the one thing you want to find is you want to find associated crania, bits of the skull, with the ear bones as well. The ear bones are arguably the most diagnostic aspect of the skeleton. You can essentially name almost species level, genus level attributions to the ear bones when you find them isolated. So if you can find them with a skull, that's even more incredible. And you can actually start to figure out what was Leviathan doing, what kind of prey was it actually feeding on, whether or not it was feeding on other whales when it was alive, like modern orcas, but mano a mano, just one whale against another whale. Like, that's an incredible thing to do, in the same way that the megalodon would have done 5 million years ago, or whether or not it was eating something else. So if they can find a skull in Peru, if we can find evidence here, I hope that we'll be able to find that. That would be the holy grail for me. I'll give you an example. Prior to 2012, there were 4 known elements, 4 bits of bone known throughout all of Australia for this group of birds called Telegonus. Telegonus is a terrifying pseudo-toothed bird that is thought to be the largest flying bird of all time. They had an incredible lifespan. They lived all the way from about 60 million years ago right up into the beginning of the Pleistocene at about 2.6 million years ago. And they have these bizarre pseudo-teeth structures in the beak. They are really, really terrifying looking animals. And since that time, since 2012 and 2016 in particular, we found, we've tripled the amount of material that we've ever found for this bird. And I think a lot of it comes down to doing citizen science and education as well, and going to the people that are going out into the field and saying, hey, this is what this looks like, you should keep an eye out for it as well. Getting them to come into the lab, handle the specimens and go, okay, this is what I need to look for. And then giving them that kind of knowledge that they can go out and continue to make these amazing discoveries. And it's absolutely astounding, the amount of material that we've been able to find for that specific bird, let alone the rest of the whales and the sharks that we've been able to find over the last couple of years as well.
I was in North Carolina last year in August, and I was sitting on the Potomac with my cousin, and we just sat on the edge of water and sifted the water with our fingers and pulled out very small shark teeth.
Yeah, that's amazing.
It's incredible.
I know Florida is basically entirely sedimentary as well, which has made me want to, like, you could just dig in your own backyard and I'm sure you might actually be able to find something. In Australia, it's significantly rarer because we don't have the same tectonic forces acting on our continent. We're in the middle of a gigantic plate, and so the active areas of erosion tend to be around the coastline, and that's almost entirely where you find and make a lot of these discoveries. And so to find the bits of teeth and penguin bones and gigantic jaws, I need to go diving half the time. I need to go snorkeling and free diving and hold my breath and prospect the bottom of the sea floor in order to find it.